Hi guys, welcome back to the show. So guys, remember that you can send in your questions on Facebook and WhatsApp. We're currently busy with first principles this week. We have a question from Junior based on first principles. Let's have a look at what Junior's question is.
We tenfold. I'm Junior, aka Lisa from Lenasia, Azara Secondary School, currently doing grade 12, Manik. So could you please help me with this question? Please, June is around the corner, and the maths, shy. It's no child's play.
Okay, Junior, thanks for that question. It is quite a nice question over here. I've got to manage to get it down in the Wacom so we can all look at it at home. So the question says as follows. Given f of x is equal to x squared, determine f of 2 plus h minus f of 2 divided by h. Okay guys, so if we look at this question, it looks very similar to what we know as the differentiation from first principles. However, it's not quite the same because we haven't been taking the limit yet. So what they want now is that we've been given some value of x, which is going to be 2, and we want us to evaluate f of 2 plus h. So we're going to substitute all of those into the formula, and then we're going to see what it gets us. So first of all, we've been given f of x is equal to x squared. Now, they don't want us to have f of x. They want us to have f of 2 plus h. So I'm going to write that down in a separate step. I'm going to have f of 2 plus h is equal to, my x was 2 plus h, and that's all going to be squared. I'm then going to multiply this out. So I'm going to have 2 plus h multiplied by 2 plus h. Guys, I like writing down my brackets because then I make sure that when I multiply out correctly. And that's very important because you don't want to lose marks in exam for silly mistakes. So we have 2 times 2, which gets me 4. We have 2 multiplied by h, which gets me 2h. Again, I have h multiplied by 2, which gets me another 2h. And I have h times h, which is h squared. So if I simplify this a little bit more, I get 4 plus 4h plus h squared. Okay, so this over here is going to be my f of 2 plus h. So that's the first part of my equation. What I want, however, is f of 2 plus h minus f of 2 divided by h. So again, I'm going to write down that next part. I'm going to write down f of 2, and I want that to be, it goes into my formula, which is going to be x squared. So I'm just going to substitute, wherever I see x, I'm going to substitute it with a 2. I get 2 to the power 2, and that equals 4. Okay guys, so this is very useful for when you start doing differentiation from first principles. Another nice method is to write down all your parts separately first, and then what you do is you take all these little bits and pieces and you plug it back into your formula, and you make sure that you don't make mistakes. This is another way to avoid that sign error with f of x plus h minus f of x. So if you write down all your parts first and then just plug them in as is, that means you can eliminate making that error. So let's carry on with this part of the question. So guys, remember we wanted f of, was it 2 plus h, if I remember correctly? Yes, it's f of 2 plus h minus f of 2, and that's all divided by h. So if I substitute in what I found for f of 2 plus h, I get 4 plus 4h, 4 plus 4h, and it was added to h squared, plus h squared. I'm then going to subtract f of 2, which is minus 4, and this is all going to be divided by h. So if I just cancel a couple of my terms here, 4 minus 4, my 4's are gone. I'm then left with 4h plus h squared divided by h. Okay guys, so like I mentioned in the very first part of this question, it looks very similar to differentiation by first principles. The only problem is we're not taking the limit as h tends to 0. But it does give us a little bit of, we can actually prepare for when that does happen in the next part of the question. So I'm going to do that now by taking out a factor of h. I'm then left with 4 plus h, and that's going to be divided by h. So I can then cancel or divide through by my h's, and I'm then left with 4 plus h. Okay, so let's have a look at the next part of this question. So guys, like I said over here, the next part of this question is going to be when we take the limit as h tends to 0. Let's have a look at that part over there. So it says here, hence, determine the limit as h tends to 0 of f of 2 plus h minus f of 2 over h. Hey guys, so I hope you recognize this over here. This part was from question number 1. And we just found that to be equal to, if I remember correctly, it's equal to 4 plus h. So that part over there is equal to 4 plus h. But now I don't want 4 plus h, I want the limit as h tends to 0 of 4 plus h. So I'm going to write that down as h tends to 0 of 4 plus h. So guys, when I'm taking the limit, okay, so when I'm taking the limit as h tends to 0, I'm then basically substituting in h as 0. But don't take my word for this, because this does change next year when you start doing the actual definition of limits when you start going to university. But for now, when you take the limit as h tends to 0, you're just substituting in as h as equal to 0. So if we do this, we're going to have 4 plus 0, and that's going to get me equal to 4. Okay, let's have a look at the last part of this question. So the next part of the question says, interpret your answer to question 2. Okay guys, so what this means is we've just found that the limit as h tends to 0 of f of 2 plus h minus f of 2, that gave me an answer equal to 4. Okay guys, so this means a whole bunch of things. Because I have a constant when x is equals to 2 as my limit when h tends to 0, so that means when I get to 2, I get a constant value. So what this means is if I've got some sort of graph, and I've got my graph over here is going to be, if I just remember correctly, my graph over here is x squared. So guys, my graph was x squared, it's a nice lovely parabola, and at this point 2, as I take the limit as h tends to 0 at this point 2, I get a constant value. So what that means is, at this point, I have a straight line. Okay, my gradient at that point is equal to 4. So if I've got to draw a tangent to that point, let's actually draw it down over here for us quickly. If I have a parabola of x squared and I've got a point over here 2, at that point, if I have a tangent, I can say straight away that the gradient of this tangent is then going to equal to 4. So that is exactly what that question means. So Junior, thank you very much for that question. It's a very interesting question. It brings a whole bunch of concepts in, and it was a very lovely question. Guys, we're going to then go to another question very shortly. Stay tuned.